Hi, welcome to the mathcenter.com. In this video, we are going to solve a problem, a pure maths problem involving arc lengths. I have abbreviated the question on the right hand side of the board. We are given a curve, and this curve that you see here is called an astroid. A-S-T-R-O-I-D, not asteroid. This is astroid. So we're given a curve, it's called an astroid, and we're given the parametric equations. Okay, the parameter here is theta, x equals to 2 cos cube theta, and y equals to 2 sin cube theta. Okay, these are the parametric equations of this curve, and you're asked to find the length of the curve ABCD. Okay, so that's one way of writing the question. I hope that everyone can follow what I'm trying to say. I'm trying to find the length of this whole curve. So I labeled it A, B, C, and D. So I have A here, B here, C here, and D here. Okay, so we're trying to find the length of the curve. So we'll use the principle of arc lengths. We have covered arc lengths in pure maths. In our further pure maths classes, we have talked about arc lengths. So we'll use those ideas to work out the perimeter of this curve. Okay? Great. What we'll do is, we will work out the length of AB again. We'll work out the length of arc AB, and then we'll multiply that by 4. And we're done. Okay? So that will be the strategy. We'll work out the length of AB, and then we'll multiply that by 4, and we're done. So, involves a little bit of work. So just to review, we are using the idea ds squared equals to dx squared plus dy squared. So this is the fundamental idea when we deal with arc lengths. So let's divide throughout by d theta squared. So I have, okay, so this is something that we have covered in our video classes when we studied arc lengths. So now we can write the square root. ds d theta will be dx d theta holding squared plus dy d theta holding squared. So we have ds d theta will be equals to the square root of dx d theta holding squared plus dy d theta holding squared. Great. So now we can write ds as equals to, bring the d theta up. Okay. So bring this d theta up, and now we can write it in the form of an integral. So arc length will be equals to the square root dx d theta holding squared plus dy d theta holding squared d theta. Okay, so we have a ds and a d theta, so we can write down our next line as s, the arc length, as equals to the integral. Let's write in theta 1 to theta 2, the square root dx d theta holding squared plus dy d theta holding squared. Okay, this integral, I repeat, is with respect to theta. So this idea that we're going to use, so let me write it down here. Okay, s will be equals to limits going from theta 1 to theta 2. Okay, square root dx d theta holding squared plus dy d theta holding squared and d theta. Okay, so this is the formula that we're going to use to find the arc length. Again, let me remind you of the strategy. We're just going to find AB and then multiply that by 4, and we are done. Okay. Okay, let me erase this part. That was just a quick review of the formula for arc length. Now let's start. Let's start with x. 2 cos squared theta, 2 cos cube theta. So we can write dx d theta. Okay, differentiate. I have 2 here. Cos cube, bring the 3 down. I have 3 cos squared theta Forget about the power. When you differentiate cos theta, you will get minus sine theta. Again, x equals to 2 cos cube theta. Leave the 2 alone. Okay? And we're going to differentiate cos cube theta. Bring the 3 down. Reduce the power by 1. Then you forget about the power and you differentiate cos theta. You will get minus sine theta. So what do we have here? We have got negative 6 cos squared theta sine theta. Okay? 2 times 3 is 6. And I have a negative here. And we're done. Then let's do the same for y. We are given y is 2 sine cube theta. Same ideas. Okay? dy d theta. Leave the 2 alone. If you like, you can think of it as the UV rule. Okay? Much easier than that. So, differentiate sine cube theta. Bring the 3 down. Reduce the power by 1. Forget about the power and you differentiate sine theta. You will get cos theta. So, you will get 6 sine squared theta cos theta. Okay? So, let's write down the important things here. We have dx d theta. Okay? Negative 6 cos squared theta sine theta, and dy d theta will be equal to 6 sine squared theta cos theta. Okay? A quick check. Dx d theta, negative 6 cos squared theta sine theta, and dy d theta will be 6 sine squared theta cos theta. So now what we need to do is look at our formula here, plug in what we need, square things out, and perform the integration. So let's do that. Okay? So let's do that. So dx d theta, let's write that down again here. Negative 6 cos squared theta, sine theta. Okay? Dx theta is negative 6 cos squared theta sine theta. So therefore, dx d theta, all things squared, will be what? Good. 36 cos to the power of 4 theta sine squared theta. And dy d theta, let's settle that as well. Okay? 6 sine squared theta cos theta. Therefore, dy d theta, all things squared, will be equals to 36 sine to the power of 4 theta and cos squared theta. Okay? So, all I'm doing is just squaring this, 36 cos to the power of 4 theta sine squared theta, squaring this, 36 sine to the power of 4 theta cos squared theta. Good. Now, remember we are only looking at AB, the first quadrant here. So, let's write down a few things. We're looking at the values of theta, okay, going from 0 to pi over 2. Okay, we are looking at values of theta going from 0 to pi over 2, and let's write down our integral. Okay, 0 to pi over 2, the square root, 36 cos to the power of 4 theta sine squared theta plus 36 sine to the power of 4 theta cos squared theta d theta. Let's check. We're using this formula. The values of theta going from 0 to pi over 2. Let me just make a note here because we are just looking at the curve, first quadrant. Okay, the curve in the first quadrant, AB. So the values of theta go from 0 to pi over 2. So there you have it, the upper limit and the lower limit. And we have a square root, dx d theta squared. Just break this down here. And then we have dy d theta squared. Just take this and bring it down here, and don't forget the d theta at the end. Now what we are left with is solving this integral.